Welcome back everyone, Patrick here, and moving on to the next factoring video, we have to write a three-term expression that has the following greatest common factors over here. So notice we're going to have to write four different expressions where one expression is going to have this greatest common factor of 5, this one x squared, this one 7y cubed, this one negative 3x squared y cubed z. Now there's an infinite amount of solutions for this, and the way I recommend doing this is basically taking these greatest common factors and multiplying it by a three-term expression here and then just expanding it. But the important thing is you have to make sure that whatever expressions you put here in the bracket, that there's no other common factor you could take out of those, because if there is, then that means that this 5, this expression here, this value won't be the greatest common factor. So let me show you. You can pick anything here, so let's say we pick something like 3 plus x plus y. Notice that from these three over here, there's no other factor you could take out. So we have a 3. Notice here in front we have a 1 and 1. There's no common factor from that. And then notice that there's the three expressions, they don't contain, none of them contain a same variable. So this one has x by itself, this one y. And so this would be an example of something you can multiply. So when we expand this, we would have 15 plus 5x plus 5y, like that. Okay, so something like this over here has a greatest common factor of 5. Now let me show you if you made a mistake of creating a three-term expression here that had another factor. So let's actually work with this, but we'll have 3 plus 6x plus 9y. Okay, what if you multiplied it by this? Well, that would be wrong, because notice that from these three, you could actually take out a 3 from all of them. And so if we expanded this, so we'd have what? 15 plus 30x plus 45y. Okay, and now let's factor this over here. So 15 plus 30x plus 45y. If I asked you to factor this expression, take out the greatest common factor, well, notice that the greatest common factor wouldn't be 5, it would actually be 15, because you could take 15 out of this, and out of this. So it would be 15, and you'd end up with a 1 plus 2x plus 3y, like that. So the greatest common factor would be 15 in this particular case, right? Or over here, if you took out a 3 from these three terms, you'd have 5 times 3, which would give you 15, and in the bracket, you'd be left with that term right there. So whatever you multiply over here, whatever three-term expression you're going to multiply that greatest common factor by, you got to make sure that that three-term expression doesn't have another factor you can take out. And so it's best to just mix it up with numbers and then different kinds of variables. And to be honest, you could actually, for all of these, you could just take this bracket maybe and then multiply it by all of these. You'd still end up with different expressions because these greatest common factors are different, but let's switch it up. Let's try some different kinds of combinations. So let's say we're going to take this x squared, we'll multiply it by maybe x squared plus 5x minus 1. Let's multiply it by a quadratic. And notice here, no greatest common factors you could take out, right? The x's are only in these two expressions, not in here, so you can't take out an x variable. And then notice between 1, 5, and negative 1, there is no integer factor you could take out. And so expanding this over here, you'd end up with x to the 4 plus 5x cubed minus x squared. Okay, so that right there is an example of an expression where x squared would be the greatest common factor. And then you could quickly check. Okay, you could pretend like you got this question here and they're asking you to take out the greatest common factor and just make sure that it's going to be x squared. Over here, let's try something different. Let's try just 3 different variables like that, x plus y plus z, right? There's obviously no common factor you could take out from here. So if we expand this greatest common factor in the bracket, 7y cubed times x would give us 7xy cubed. 7y cubed times y would give us 7y to the power of 4. And then 7y cubed times z would give us 7y cubed z, like that. Okay, so this expression has a greatest common factor of 7y cubed. And then over here, let's maybe, let's make this one really complex. So let's add some numbers to these. So let's do 5x plus 2y minus, let's say, 7z. Okay, again, you could pick whatever you want over here. It could be as simple or as complex you want to make it. I'm making this one a little bit more complex. I added different variables and I added numbers. And notice from the numbers, there are no common factors between 5, 2, and 7 that you could take out. Okay, so if we expand this, just be careful with your algebra here. So we'll have negative 3 times 5, which gives us negative 15. X squared times x, add the exponents, you'll have x to the power of 3, then you'd have y to the power of 3. And then you'd have z. Then you'll have negative 3 times positive 2, which would give us negative 6. X, there's no x here, so it would just remain as x squared. Y cubed times y, that would be like y to the 4. And then we'll have z, like that. So we multiplied there. Let me just make sure. Quick double check. Yeah, it's all good. And then this, we would multiply by this. So negative 3 times negative 7 would give us positive 21. X squared, y cubed. Notice there's no x and y over here, so that would just remain x squared, y cubed. And then we have a z to the power 1 times z to the power 1, which would give us z squared. Right, so that's an example of a fairly complex expression where if you factored it, the greatest common factor would be this negative 3x squared y cubed z. Right, so that's how you do these kinds of questions. Just multiply the greatest common factor by an expression, whether it's a 2-term, in this case it's a 3-term expression. Just make sure that what you're multiplying by, there's no other factor that can come out.